to start off today's notes, the first thing that I would really like to clarify is the connection between what we said is the same when we're talking about shrinking horizontally and which one was it? Vertical stretch. So see, we have a notation here, f of 3x, and that 3 is on the inside. That's my, right? That's my coefficient. And here, f of cx, so that could have been a 3, for example. It says shrink horizontally. So make a note. Vertical stretch. In the table, yes, we're going to go over it. So in the video I mentioned we would talk about how when something shrinks horizontally, it's the same as a vertical stretch. So really visualize that, right? So if something shrinks horizontally, right, it's going like this, what's happening to it if it's getting shrunk horizontally? Right, visually, if you literally take your hands and hold them up like this and you come in, that graph is getting skinnier, which is the same as being stretched, pulled apart vertically. See how that motion would create the same graph? Are you seeing what I'm saying? So shrinking horizontally this way, right? If you bring your hands close together, it's making it skinny, skinny, skinny. It's the same action as if you had started from a vertical motion and pulled it apart. Yes, question? That would be how we actually, she's asking what does this 1 over c mean? It's how we would actually modify an x value if I was given a point. So for example, if I was starting with an ordered pair 9, 1, for example, and we were looking at f of 3x, that makes c 3, correct? Mm-hmm. So what would 9 times 1/3 be? 3. So the new ordered pair in the translated graph would be 3, 1, because 1/3 times that starting x value is 3. Our sketches, though, we're sticking to a much more general sketch, but this is still the fact of if we were literally going to translate points, what would that look like? Yes? Awesome. Applying the same idea to this next line, this one was which letter that we looked at? 5? Nope, not 5. Did we do one here yet? 10. It will be 10. What did you guys write for 10? E. Who wrote E? Very good. What did you put for words? Horizontal stretch. Very good. So this is E, horizontal stretch. And let's go make a connection back up to the table. Here, the language matches much more directly, right? Horizontal stretch, stretch horizontally. So how come it just didn't say stretch vertically for the other one? It could have. So her question was, why could this not have just said stretch vertically? Because who made this table as part of notes decided to use that vocab. But now that we visualize, it means the same. Very good. So let's finish comparing answers. What do we get for number 2? I. Good. What did you write for words? Good. Three? Who said A? Good job. Pay attention to the location of the negative sign. The negative sign is on the inside. So are you reflecting over the x-axis or the y-axis? The y-axis. Reflect over y-axis. And to show that visualization that was in yesterday's notes, this is the difference. So if I have the negative on the outside, we are reflecting that graph, literally flipping it over the x-axis. But if my negative sign is on the inside, you're flipping that graph over the y-axis instead. So the location of the negative. If the negative is outside, you're reflecting over x-axis. If the negative is on the inside, you're reflecting over the y-axis. Very good. Number 7? Who said C? Good. C. People who said C, let's help people who put J realize what you did, what your thinking was for C. What did you say? Down 2. So let's see what J looks like. What's the difference between this one and what this one says? It's on the inside. So if it's on the inside, would that be a horizontal or a vertical shift? Horizontal shift, left or right? Left how many? Yes, so this would be left 2, but this is outside, down 2. Good. 8? F. Yes, F. This is a reflection over, we just talked about it. Good job. Because the negative is where? Outside. Yes. And finally, number 9? J. And we just discussed that would be a shift left 2. Good. So let's pick up with our note, rewriting a function in terms of another function. Rewriting a function in terms of another function. It's really not too bad, but it's going to be a good conversation right now. The best way to practice and learn is to learn is to practice it. So let's look at number 15. The graph of the function g was obtained from the graph of the function f using a transformation as shown above. Based on the graph, which equation can be used to describe g of x in terms of f of x? So now how many functions do we have in play right now? 2. There's 2. So if you have your colors, I see most of us do, colors will help us out here to keep track of what's what. So let's designate a color for F. How many colors? 2. 2 colors. A color for F and a color for G. The key for these types of questions is to really know where are we starting. So if you reread that first sentence, can you tell me what my starting function was? G, F. I'm going to give people a chance. I'm hearing F and G. Take a moment and read and see if we can make a choice. Yes, it is F because the graph of G was obtained from F. So F is the start. That's what that first sentence means. F is where we started. And now my second sentence says, based on the graph, which equation can be used to describe G? So this is where I'm starting. This is where I ended up. How did this graph transform from where we started to where it is now? So the first comment was a reflection, which is a good point because it does look like it's on the other side of the y-axis. But if this started as an increasing graph on the left side of the y-axis, if it was reflected, what would it look like? Decreasing. Now, we don't see that kind of change with a parabola, right? Because if you were to make a U with your hands and you flip a U over, what is it still the shape of? It's still a U. So that's why this wouldn't necessarily be a reflection, but good thinking because of the location. So if we know it's not a reflection and it's what kind of move is happening here? a shift right 3. So, 6. So if that's what you observed, let's write that down. Shift right 6. That's what's happening. It's shifting right 6. Which of these answer choices demonstrates a shift right 6? Very good. Good job. That's right. So the key is using our colors to help us see what's what and really identifying where are we starting. So let's practice that with 16. The function h of x is shown. If f of x equals x squared, write h of x in terms of f of x. Woo! Okay, so let's break this down. What graph is shown right now?
H. Yeah, h of x.
Yes. Maybe I should use my skinnier highlighter. So this is H. Okay, now we know what's what. H of x is shown. Now it says, if f of x equals x squared, what function would we call this? Yes? I'm thinking of a vocabulary that starts with a P.
Parent function?
Parent function. Has any change occurred to this function?
No.
No. This is my parent function. So if f of x equals x squared, let me get that in my other color. We could also label this h of x. I need to write h of x in terms of f of x. So what was done to f of x to get this graph?
Move to the right.
One person's seeing it, but I want us all to see it. So here's another strategy. Has f of x been graphed?
No.
Well, could we graph it?
Yeah.
We know what the parent function looks like, right?
Yeah.
So let's get it on the graph. So now we have f of x on the graph. So if f of x equals x squared, I need to write this h of x function. How? Where did h of x come from if this is where we had started? What was done to the graph? Shift right 7. So then h of x equals what? F of x minus 7. Yes, question.
If you say it the same way, like if you still say f of x minus 7, then why can't in the other problem on 15 can't you say c?
Great question. So the question was, back up here, why could we not write C as the correct answer? If I look in both of these cases, what kind of shift was taking place? A shift right. And think even back to last week, what is inside those parentheses with vertex form, H or K?
H.
H. And what kind of shift is H? Horizontal. So that horizontal shift only happens inside parentheses. What shift happens outside parentheses? Vertical. Very good. So, to her point, if this had been shifted up or down, let's say this had been down 7, where would this minus 7 have been?
Outside.
Outside. We'll check, yeah, okay. Yes, leave it at that. 17, we learned by practicing, so let's try again. 17, the function p of x is shown. If f of x equals x squared, write p of x in terms of f of x. Let's get our highlighters going. P of x is shown. So that means that I'm going to highlight this with the same color and label it P of x. If f of x equals x squared, write P of x in terms of f of x. What quick little sketch can I add to this graph to help me see it?
F of x?
Yes. So let's sketch f of x, our parent function. Let's get our parent function on the graph. So now we need to write P of x in terms of f of x. Let's first decide what's been done to the graph. Has our graph been shifted left or right?
Right. Oh, yeah, left.
Left, how many?
6.
Left 6.
Up, comma.
So what people are seeing is literally left 1, 2, 3, 4, 5, 6. Left 6, up 3. So now that we've identified our shift, what are we going to say about f? F of plus 6 plus 3. Because this is what's been done to f to get to that given p function. The function f has been shifted left 6 and up 3, which results in the given p of x function. Comfort level 1 to 4. 1 being, oh my gosh, 4 being confident. Where are we right now?
3.5.
3.5? I'll take 3.5. Very good. Let's keep practicing. 18. Oh no, there's no graph. The world's over. No, it's not, I promise. The function s of x is a translation of f of x equals x squared. So just because we don't have graphs, that's okay. Let's still get our colors going. And s of x has a vertex at 25, negative 9. Write s of x in terms of f of x. Then write the equation of f. So this is going to be a two-part question, okay? Let's just take it a piece at a time. Where's our starting point?
25.
Read that first part. The function s of x is a translation of f of x equals x squared. So where's my starting point? The parent function. This is my start. So if this is my start and this is my end, this is where I'm ending up, and I'm told that the vertex of s of x is 25, negative 9, what shift of the original vertex has taken place to get here? Right 25, down 9. Right 25 and down 9. So now we need to write s of x. We've identified our shift. That was the first thing we need to do. Now we're going to identify or write our equation of s of x. S of x equals what? F of x minus 25. That's our right 25 minus 9. And we're done.
What's the equation?
That will be our equation. That's as far as we can take s of x. Oh, I see what you're saying. We only answered the first part, right?
Yeah.
So let's move this over. So this was writing the function in terms of the parent function, but now it says write the equation of s of x. So can we kind of take f out of it, so to speak? Can you give me a function that demonstrates right 25 and down 9 in vertex form?
X equals x minus 25 minus 9.
X minus 25 squared minus 9.
So that's how I get it into a vertex form.
So here we have s of x in terms of f, and here we have our direct equation of s. Let's practice again. 19. The function h of x is a translation of f of x. Yes, so right there. Stop right there. Let's get our colors going. So h will be yellow for me, and f of x, I'm going to keep that blue. So right from this first sentence, we know we're starting where? What's our start? Parent function again. Here's my start. The function h of x has a vertex at negative 12, negative 15, and has been vertically compressed by a factor of 1/4. Write the function h of x in terms of f of x. Then write the equation of h. So we have the two parts again. Let's first talk about what's been done. Tell me in words what's happened so far. What do we know? This first shifted left 12, down 15. But is that it?
No, it's got horizontal shift.
It's been vertically compressed. So put your hands like this, one on top, one below. Vertically compressed means your hands are going to get closer together or farther apart? Closer together. So vertically compressed. Now put your hands side by side. How would I represent this, but now starting here? What are your hands doing? Go out. So if you talk horizontal direction, like vertical compression is the same as horizontal stretch. So what is this a value for? Think about vertex form. What is this a value for? A. Very good. That's a value for A. So let's first start off by writing h in terms of f. So h of x equals, how are we going to put this together?
1/4 f.
1/4, good. We have a new a value, 1/4 f of x plus 12 minus 15. So that's piece one. But now we're told, write the equation. So straight up, vertex form of this function, accounting for both of these translations, would equal what? 1/4 x plus 12 squared minus 15.
So you kind of just take out the f.
Yeah, so we're really just mentally visualizing. If we take out the f of x, what needs to get added in? The square, and then the f is gone. Which kind of makes sense, right? Because that f of x equals x squared. That's your squared part.
Oh.
Right? So we're removing that from our equation and then adding it back in the square to account for it. Awesome. Let's look at 20. Given the graph of g of x equals this, so let's get our colors going. This is what I'm given. Now we have some new instructions here. In A, it says graph m of x equals negative g of x. So before we start trying to even think of like what we're going to graph, what does this mean? What's been done?
Oh.
What's been done in words?
It's reflection over the x-axis?
Very good. Reflection over x-axis. What's that going to look like?
Not just like the same, but like on the upside down.
Well, what's the distance from here to here? 4. So my vertex, instead of counting up 4, we're going to count down 4. 1, 2, 3, 4. Has any other kind of change happened other than the reflection? No. So do the best of your ability to kind of sketch the same width. Nothing else has happened. And with that, we have successfully reflected over the x-axis. So we have to be careful because what could we think by accident that happened here? We could think, I was thinking we could think a vertical shift down, but this is a direct reflection. So if I count 1, 2, 3, 4, and then I count 1, 2, 3, 4, it's the same distance away from the x-axis, that is the indicator to me that this was a reflection. Now, yes, and it's upside down. It changed directions. Instead of opening up, now it's opening down. Good. B says graph K of X. If you have a third color or your neighbor has a third color, borrow it from them or grab one from the bucket. Graph K of X equals G of X plus 5. Don't even think of the graph. Let's start with words. In words, what's happening?
It's a horizontal.
Shift.
Yeah, horizontal shift.
Where?
Left.
Left.
5.
5. So we're going to take our vertex where we're starting and go where? Left. 1, 2, 3, 4, 5. Any change in the width at all?
No.
No. So again, with your sketch, do your best to maintain the original width. We have successfully shifted the graph left 5. We're done. So if you want to visualize our first part, m of x literally reflected over the y-axis. Reflection, excuse me, need some more coffee. Reflection over the x-axis, whereas k of x was a horizontal shift left 5. Part C says, write the equation of k. So we're being asked for no k in terms of g, just a straight out function for k. What would that look like? K of x equals 2. We still have the same width. X plus 5
Plus 4.
Where is that coming from?
On the parent
Ooh. What's our starting function?
x minus 3 squared or 4.
So if you want to take your starting color, let's identify the pieces that came from the start. What pieces came from the start?
2.
2.
Negative 3.
So notice when we're writing k of x, this is our start. What's the only piece we are adding?
5.
Yeah. Here is our addition of that shift left 5. Yes. Yes. Our last step will be to combine like terms. So our answer will be k of x equals 2. What are we going to have inside parentheses? X plus 2. Finish it. Squared, yep. Plus 4.
Oh.
So color's really your best friend here. They help me see it. So if they help me see it, because I'm a very visual person, for all of us who are very visual learners, keep your colors with you for transformations, okay?
So then if you were doing it from 0, that's how that would work out.
Yes. So the question was, if we had been starting from our parent function, could we have just said x plus 5 squared?
Yeah.
Yes, we would have been done. The difference is we were starting with a function that already had a horizontal shift, already had a vertical shift, and an a value, not 1. So all 3 of those pieces had to stay present when we did our new writing. Yeah? All right, very good. 21. Write p of x in terms of n of x. So we need 2 colors. P of x. Which of these graphs is p of x?
The one on the right.
The one on the right. Making the other one n of x. Where are we starting?
The back. N. No.
N. So if you want to make a note, that means that on the graph, this is our start. Figuring out where we're starting is one of the most important pieces. So if this is our start, because this is n of x, how do we get from n of x to p of x? What's happening? Let's always have a habit of looking left and right first. So if I'm looking left and right, go ahead and see if you can count and let me know what's happening. You count.
10.
Right 10, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right 10.
Up 5.
I hear 4, I hear 5. Let's see. 1, 2, 3, 4. Very good. Right 10. Up 4.
Like, how do we write it if we don't know what the first one is?
Great question. The question was, how do we write p of x if we don't know what n of x is? Could we start by writing n of x?
Yeah.
Do we know how to do that?
Oh, yeah.
If I mentally visualize my parent function, what is n of x? What's been done to get n of x in the first place? Let's think left and right first.
Left 6. Down 5.
So left 6 down 1, 2, 3, 4, 5. Left 6 down 5 would look like what? X plus 6 squared minus 5. So now incorporating right 10 up 4, P of X equals what?
N.
Do we want to start with n, or can we just straight up write our function incorporating this? X plus 6 minus 10
Squared. Minus 5 plus 4.
Very good. Our final function would be P of X equals So I got all excited because we could do what we just did. We did take this a little farther. I just realized. So let me fix that mentally for you guys. This technically said just write P of X in terms of N of X, yes? Mm-hmm. So what she had said technically was as far as we needed to go, but come on, that was like so much fun. So if we were just to strictly write it, P of X equals, in terms of N of X, N of what? Yes, because that's what you're doing to n. So if I had then asked you, write the function P of X, this is what would have happened. So this is what P of X looks like in terms of n. And then what we did was kind of a follow-up, that part B we had looked at before. What would the actual function be? So we just actually got double for our money out of that question. Awesome. 22. So here we will make sure we stay within the rules of what we're asked for. We won't go farther. 22 says write M of X in terms of D of X. Let's get our colors. Colors. M of X is right here. D of X
Good morning, East Hartford High School. Today is October 28th. Please stand for the pledge.
I'm going to pause this. Picking up where class left off on number 22. So when class ended, we had just highlighted M of X and identified it with our yellow highlighters on the graph, and then D of X in blue with the graph here. This is given as D of X. The directions are to write M of X in terms of D of X. So that tells us that D of X is our start. So we should write start. So we're not actually going to try to write this function. We're just going to look at what effect must have taken place, what transformation must have happened to get from here to this one. So the first thing I want to point out to you is that I know for a fact this is a reflection over the x-axis. And let's discover why I know that. When I look at the distance from the vertex to the x-axis, it's 2. From here to here, the distance is 2. And from here to here, the distance is 2. So I know that this entire graph has been flipped. It's been flipped over. It's a reflection over the x-axis. So let's write some notes down. First, about the reflection. Reflection over x axis. That's the first thing that's happened. So to help you visualize it, you don't have to draw this if you don't want to. But just looking at the reflection, I would be here. So this represents just the reflection. Then you have to ask yourself, once it was reflected, what happened to it next? Well, next, it was shifted left. How many? 1, 2, 3, 4, 5. Shifted left 5. And once it was shifted left 5, we ended up here at m of x. So now let's see how we can work on writing m of x in terms of d of x. This will be m of x equals a reflection over the x-axis is when we have that negative on the outside of our function. So m of x equals negative d of x, and now a shift left 5 would be x plus 5. And I'm done. So the negative that's out front that I've made super bold to try to make it stand out, this is how we account for the reflection over the x-axis. And then plus 5, recall, there's a built-in negative that becomes a plus. Shift left 5. Moving over to 23, process is going to stay the same. Write m of x, and I look and I find m of x in terms of d of x. And then I come over here and I find d of x. Then we ask ourselves, where am I starting? Once again, d of x is my start. So visually, I'll help myself know that by writing start over here as well. Give you a moment to take a look and see what happened first to this. Once again, we have a reflection over the x-axis. So first what happened was this was flipped. And to account for that, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. First we had a reflection, so we know that that will be a negative out front. Now, to get from the original reflection, we are actually going to have a horizontal shift and a vertical shift. So this was the reflection, which will be negative d of x. Next, we have a horizontal shift, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's add that to our list. Shift left 10. And then last but not least, up 2. Shift up 2. So now we have 3 transformations to account for. M of x equals, first will come accounting for the reflection. So negative, again, negative d of, shift left 10 will be x plus 10, inside parentheses, shift up 2 plus 2 outside of the parentheses, and we are done. (24) says, for each function, first, so we have parts here. First, identify the parent function, f of x. Then, describe the sequence of transformations from f of x to g of x. Lastly, use function notation to write g of x in terms of the parent function, f of x. So we're going to take this one piece at a time. When it says, identify the parent function, f of x, what that will look like in this first question, I see that I'm dealing with a function that's to the third power, which means my parent function f of x will be x to the third. That's my parent function for this question. Once I can see my parent function, now I can visualize a lot easier what's been done to it. So I'm seeing a horizontal shift on the inside and a vertical shift on the outside. When I see x minus 1, I know that that will be a shift right 1, that positive 2, up 2. And C asks us, use function notation to write g of x in terms of f. So f is my parent. Let's finish discussing what's happened to the parent function. Well, I'll pull that information right from B. So f of right 1 would be x minus 1. Vertical shift up 2 plus 2, and I'm done. Now that we have a feel, take a moment and see if you can identify what is the parent function for question B. I see that my highest power is 2. Therefore, my parent function is x squared. Next, we ask ourselves, what transformation has happened? Describe the sequence of transformations from f to g. So this is where we started. Like over here, this was our start. Here, this is now our start. What is happening to this parent function to become what we see here? So let's stick with our habit of using our highlighter. I see a horizontal shift on the inside, this vertical shift of 3 on the outside, and I have an a value. So we have 3 pieces to account for. Let's start with what we see on the inside of parentheses. The minus 4 on the inside of parentheses tells me that this will be a shift right 4. The positive 3 on the outside that's being added could have been over here. Same thing. I could have seen this positive 3 as added at the end. Means a shift up 3. And now let's talk about this a value of 2. 2 is greater than 1. So I know that this will be a vertical stretch. Vertical stretch. It's going to get skinnier. C asks, use function notation to write g of x in terms of f. So let's go down our list. Write for up 3, positive 3 on the outside, and then this vertical stretch where a is 2, that 2 will come out front. And we're done. Let's take a look at C and D. For C, first step, our parent function, I see the highest power is 2. Therefore, f of x equals x squared will be my start. B asks us, describe the sequence of transformations from F to G. So let's take a look. Let's use our highlighter. Let's figure out what's been done. I see a plus 5 on the inside, plus 2 on the outside, so I definitely have a horizontal shift on the inside. I see a vertical shift, and I see this negative, which represents a -1 on the outside. Piece by piece, let's talk about this plus 5. I recall that that positive came from a double negative. So that means a shift left, a horizontal shift left 5. Positive 2 on the outside. Up 2. That negative on the outside means it's a reflection. Reflect over the x-axis. So now instead of opening up, it will open down. Question C asks us to put what we just put into words, represent it algebraically by saying, with function notation, what g of x is in terms of f of x. So g of x equals negative, because of that reflection over the x-axis, negative of what f was. A shift left 5 will be x plus 5 on the inside. Positive 2 for that vertical shift up 2, and we're done. Last but not least, question D. I see that I have a power of 3 here, so let's see what we have for our parent function. F of x equals x to the third. This will be my start. In words, let's describe what has happened. To do that, we can help ourselves see it using our highlighters first. I see a -6 there and a -1/2 out front. In words, let's start with this x minus 6. I know that that will be a horizontal shift right 6. Now let's talk about the -1/2. So this, I'm not sure if we're still recording. Okay, we are good. So, right 6 is the x minus 6 on the inside. The -1/2 on the outside, 2 pieces of information we get from this. The fact that it's negative, I know that we have a reflection over the x-axis. We also have this 1/2 to account for. 1/2 is between 0 and 1. So I know that there will be a horizontal stretch. The graph will be wider. So the reflection over the x-axis came from this being negative. The stretch comes from a now being 1/2. Last but not least, let's write g of x in terms of f of x. So I have a new a value that tells me that not only will my graph be more wider, my parabola will be more wide, but it's also going to reflect. Instead of opening up, it will now open down. F of x, right 6, will be minus 6 on the inside, and we're done. Great job. Remember to send me any and all questions on this weekend's homework on Remind. Have a great night, everybody.